Hello everyone. Welcome to yet another video on TwinSimulate. In this demo, we will look at how to acquire sensor data from an ESP32 and publish it to the Things board cloud using the MQTT protocol. Let's select ESP32 as a target in the diagram. Next, choose the ESP32 board as the target subtype. In the left-hand side panel, scroll down and search for the ESP32 library. Select the analog input block and add it to the diagram. Since we need two analog inputs, add another analog input block. Next, select the digital input block and add it to the diagram. Now, select the ESP MQTT publish block and add it to the diagram. Since we need to publish three sensor values, right-click on this publish block, increase the number of input ports to 3, and then click OK. Connect both analog input blocks and the digital input block to the ESP MQTT publish block as shown in the diagram. Now, double-click the first analog input block. Select the GPIO pin connected to the potentiometer. Then click OK. Next, double-click the second analog input block. Select the GPIO pin connected to the LDR sensor. Then click OK. Now, double-click the digital input block. Select the GPIO pin connected to the IR sensor. Then click OK. Next, double-click the ESP MQTT publish block. Enter the Wi-Fi SSID and password. Now, let's configure the MQTT parameters. Open the Things board cloud in your web browser. Navigate to the Devices section. Click Add New Device. Enter the device name. Then click Add. In the newly created device, select the MQTT tab. Copy the MQTT server address and paste it into the MQTT server field of the ESP MQTT publish block. Next, copy the MQTT topic and paste it into the MQTT topic field. Now copy the MQTT username, which is a device access token, and paste it into the MQTT user field. Leave the password field empty unless required and ensure JSON packing is enabled to receive the data correctly in Things board. Now enter appropriate key name for telemetry data. Then click OK to save the configuration. The model configuration is now completed. Next, click Generate Code and Deploy. Wait for the code generation, compilation, and programming process to complete. Once the ESP32 is programmed, it automatically connects to the configured Wi-Fi network. After establishing the Wi-Fi connection, the ESP32 starts publishing the sensor data to the Things board cloud using the MQTT protocol, and device state shows active. Now, in the Things board cloud, from the left-hand side menu, select Dashboards. Click Add Dashboard. Enter the dashboard name. Then click Add. In the newly created dashboard, click Add New Widget. Select the Cards category. Choose the Value and Chart Card widget. Select the previously created device. Under the Keys field, all telemetry keys configured in the ESP publish block are automatically displayed. Select the potentiometer telemetry key. Provide a suitable widget title. Click Add. Now, for the graphical representation of the potentiometer values, click Add New Widget. Select the chart's category and choose the Range Chart widget. Select the previously created device. Under the Keys field, select the potentiometer telemetry key. Enter an appropriate widget title. Click Add. Now, let's create the widget for the LDR sensor. Click Add New Widget. Select the Control Widgets category. Choose the LED indicator widget. Select the previously created device. Next, open the Appearance tab and enter an appropriate widget title. Now switch to the Status Settings tab. Turn off the Perform RPC Device Status Check option. Then enable the Subscribe for Time Series option. Select the LDR telemetry key. Click Add. Now, for the graphical representation of the LDR values, add one more range chart widget. Now, let's create the widget for the IR sensor. Select the Status Indicators category. Choose the Status widget. Next, open the Advanced tab and select the previously created device. Then switch to the Appearance tab and configure the initial state settings. For the action, select Get Time Series. Under the Time Series key field, select the IR sensor key. Since the IR sensor output is either 0 or 1, set the result type to integer. Enter the on-state value, then click Apply. Similarly configure Disable State. Then, under Widget Card tab, enter the appropriate widget title. Then click Add. Now, for the graphical representation of the IR values, add one more widget. Select the Charts category and choose the State chart. Select the previously created device. Under the Keys field, select the IR telemetry key. Enter an appropriate widget title. Click Add. The dashboard is now ready. Let us now observe the sensor data. Rotate the potentiometer. The chart displays the current raw value of the potentiometer, and the graph shows the real-time trend of the potentiometer readings. Next, change the light intensity falling on the LDR sensor. The LED indicator displays the brightness level detected by the LDR sensor, and the LDR graph updates in real time according to light intensity. Now place an object in front of the IR sensor. The object detection widget displays the current state of the IR sensor, and the graph displays the sensor readings in real time. All the sensor values are continuously acquired by the ESP32 and published to the Things Board cloud through the MQTT protocol. The dashboard receives the data in real time and updates the graphs continuously. This demonstrates real-time IoT communication between the ESP32, TwinSimulate, MQTT, and the Things Board cloud. Thank you. Stay tuned for more TwinSimulate demonstrations.